Okay, we're going to do 5 inequalities involving absolute value. So go back to 6th grade. Absolute value is like the distance, okay? Doesn't matter where you or how you talk about distance, is always positive. So the distance away from 0. Usually absolute value is referred to the distance away from 0, okay? So let's come out here. We're going to solve and graph absolute value inequalities right here, less than. Solve and graph absolute values, absolute value inequalities that are greater than. So absolute value with this sign right here. If you look at it, always read from left to right. So you would read, and then you would get to this one. So that, since it's pointing, I guess when it's eating away like this, and this one comes first, you can say this one's less than, that's what the symbol means, than that one. So absolute values inequalities with less than. So the inequality, absolute value of x is less than 3, means that the distance between x and 0 is less than 3. Okay, so let's think about this one, what this is saying right here. Now, when it comes to absolute value, it's saying the distance. Any distance away from 0 that is less than 3. So if I go 1, that's less than 3. 2 is less than 3. And then the right before, 2.999999 is less than 3. But it's saying the distance. I can go 1 in this direction, or I could go 1 in that direction. Do you see it? Do you see how this turns into 1 in either direction? 1.5 in either direction? It's not saying positive or negative. It's just saying the distance away from 0. Right? Less than 3. So it doesn't say if it wants to go to the right or to the left. So these are basically and statements. This translates into this. So when you read this, we're going to come out here and say that what? Let's look what this says here. X is and X is. Well, let's look at this real quick. We're going to break this down into saying, so X is greater than negative 3, which you see. These values are greater than negative 3. And these X is less than 3. So look at the symbols. So the solution set would be this here. All the numbers going this way, and all the numbers going this way. So X is between negative 3 and 3, not including the 3, no equal sign. So it goes like that. Going once, going twice. So again, if you're saying the ones that are, I guess, the distance, not positive, not negative, slash absolute value, less than 3. So we can go over this way and over this way. These values are greater than negative 3. These values are less than 3. So let's come out here real quick. So we're going to solve each one of these real quick. Okay, solve each inequality. So remember, this is saying the distance. Now, you got to think about what this, let's go back, I guess, to that example that they gave us from the book. When it's saying this, right here, remember this, I want you to draw a cheapy number line real quick. I know it's right here, but look. 0 here. And if we go to 11 all the way over here, and we go negative 11 here, these distances are all less than. So we're going to write this here. We're going to use this to our advantage. We're going to say that the numbers are what? Then 11. We're going to, oh, I'm sorry. We'll go with this part first. We're going to say these numbers are what than 11? They're less than 11. What numbers? The distance away from 0. Okay, which is in this situation, they're saying m plus 2 is the distance. So that right there, they're going to say this distance away from 0 is less than 11. But please do me a favor. Make sure you understand the idea. It's this part is less than 11. All right, this part going this way. Now, in regards to this part here, these numbers are greater than a negative 11. So we're going to come out here, and we're going to basically just, I don't ever really do this one. I'm just saying now, this part inside here is now greater than a negative 11. Because we want these numbers that are on this, you know, the distance away from 0 to be less than 11. These are what in regards to that negative 11? They are greater than a negative 11. So that's it. Set them up both and do both. Add, I'm going to subtract the 2, so we get m to be a negative, m to be, here, and to be less than 9. So a 9 here, going this way. Okay? Case 2, remember, that same thing is going to be greater than a negative 11. So now in this situation here, we're going to go to subtract 2 from both sides, and we get m to be negative 13. So from a negative 13, go in this direction. So there's my final answer, from here to here. So we actually say that your m's are between negative 13 and positive 9, like this. Now, are they included? Is there an equal sign? They're not included. There's no equal sign here, so I don't put it. And there's my final answer. Or m is my answer, such that m is what? Between a negative 13 and a 9. Okay, let's get on here real quick. Let's look at this one real quick. Now, in this situation here, this one says whatever the distance is. Okay, remember, distance does not have any negative. You can't say this is talking about a 2 if you think about it. We can't say I went negative 2 in this direction. I went a negative 2 in that direction. We don't say the distances are negative. We can't say basically the absolute value, because the absolute value is asking, I don't care which direction. How far did you go away? I don't care again if I went in the positive direction or in the negative direction. So when we talk about distance, it can't be negative. So basically an absolute value could never be negative. So this one says there is no solution. Okay? Let's look at this one real quick. Okay, so this one says the distance away from 0 is less than or equal to a negative 2. So just visually thinking about this one. I hope I didn't say negative 2, but a 2. This one, look, it's eating that one, so this one's bigger. These are smaller. Look what this is saying. This is smaller than a 2. So the distance from here to 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 here, all of that is less than a 2. Absolute value is how far did you go? I went less than 2 in this direction. I could go less than 2 in this direction. All right, so that's the idea I want to talk about. I want to go from here all the way to here. These are my answers, basically. All of this stuff. Okay, but regarding this part, let's go ahead and figure it out. So we're going to come out here and say n minus 8, you see, is less than or equal to a 2. Right, this part less than or equal to a 2. And n minus 8 for this side happens to be greater than a negative 2. Oops, forgot the equal sign here. Let's go ahead and add 8 here, cancels out here. This one gives me n less than or equal to a 10. This one right here gives me n, add 8, n is greater than or equal to a 6. So those are my answers right there. Now this one, if you think about this one, is on the left. So I'll put a 6 here. This one right here is a 10. Okay, now both of them, thank God, and both variables on the left. So from a 10, I'm going this way, shaded in, because of the equal sign. From here, at the 6, variables on the left, pointing to the right. Pointing to the left, I came this way. Pointing to the right, I'm going to the right. They connect right there. Shaded in because of the equal sign on the bottom. There it is. Next thing I'll come over here. Let's try this one. Oh wait, so my answer for this one. So the set of n such that n is between 6 and 10 and less than or equal. I always put this right here, these two symbols, and then determine if there's equal signs down here, if they gave it to you or not. Let's look at this one over here. So we're going to have here, in this situation here, it's saying this is less than a negative. What did we say right now? The distance can't be less than a negative. So basically, absolute values always have to be positive. So in this situation, this one has no solution. Absolute values cannot be less than a negative, guys. There's nothing less than a negative. If you say double negative, then double negative is a positive. So we're going to skip this one. We'll stick to this part here. Now, look at this one real quick. The other ones were like this, less than. This one's saying greater than. Whatever here, A is, you see how it's eating it? A is greater than B. So we're talking about greater than. Now, if we talk about the greater than 3, The absolute value is greater than 3. So I can go away from the 0 in positive directions and negative directions. But if I go more than 3, I went more than this 3, I'll tell you that much, or more than this 3. Now, I'm not caring about direction. I'm just caring that I went past, or more, like it says, more than 3. And that's it. So treat this idea here. Same ideas happen. The x values, look at this one right here, in this situation, are less than this one. These x values are greater than this one. So we just set that up. So let's look at this one. It says it's greater than 12. So if we look at this, has to be greater than 12. Right? Now, this stuff here, if you think about this part here, greater than 12 means the stuff going that way. This stuff says it's going to be less than, pointing that direction, of a negative 12. And that's it. Just go from there. It won't be too bad. So you got to think about, in my opinion, think of the number line. They're saying 12. So 12 is here, and negative 12 is here. The two symbols you need to have it where it's going this way, and you need to have it where it's going this way. They want the distance greater than 12, or equal. So I need to satisfy these two things. On this side over here, the information they gave me is greater than 12. There it is. Here's this one here. This information, the information they gave me, is less than 12. And there it is, less than 12. Okay, now let's just come out here and do this. Oh my gosh. Subtract 6, subtract 6. This one 3n. This comes 6 divided by 3, 2. So from 2, I'm going to the right. Here, the opposite. Okay, for going to the left, basically says I'm going to have this stuff that's inside to be less than, they're saying, than negative 12. Just regular situations. Add 6, divide by 3, and there it is. Final answer would be this, or this right here. Hold on. Okay, so let's look at this real quick, 3a. So make sure you understand what this is. This distance here is greater than 7. So I'm going to go 2k plus 1 greater than 7. Okay, I'm going to draw a cheapy number line here. For it to be greater than 7, I'm going that way. Okay, that's this one. For it to be less than, I'm going that way. So I need to set this up right here. This right here is a negative 7, and for it to be less than, I'm going to point in that direction of whatever they gave me, 2k plus 1. So there it is. Look how they both come out. Subtract 1, subtract 1. This gives me 2k is less than 6. Divided by 2, divided by 2. K is less than 3. Over here, let's look at this one right here. 2k minus 1, minus 1. We're going to go 2k is less than negative 8. Divided by 2, divided by 2. K is less than negative 4. Okay, so I'm going to come right here. Now, I know some of y'all might be thinking, sir, why didn't you switch this over? I did not divide by negative. I did get a negative as my answer, or in the answer, but I don't divide by negative, so I don't switch this. It just worked out to be a negative 4. So I'm going to grab this one here from a 3. 1, 2, 3. From a negative 4, I would stick out a little bit further than a negative, yeah. So this one right here is going to the right, not shaded. This is going to the left, not shaded. There's my answer. Finally, I'm going to go ahead and put both of these things together. So k is the answer. The set of k is the answer such that k is greater than 3 or k is less than a negative 4. Let's come over here in this one. Well, what do you think about this one? Can this one be greater than a negative 5? What do y'all think? I'll probably say I can think. Okay, what do you think about this again? This is kind of like a trick question. Think about what they're saying. When is the absolute value slash a positive greater than or equal to a negative. Which of these is this true? How about this? When would it be wrong? It would never be wrong. So guess what my answer for this one is? Anytime you see an absolute value greater than a negative, it's going to be this. All real numbers. That's just by thinking. What? Let me. I don't get it. Sorry. Well, think about it. When would a negative? I'm sorry. When would this again? What kind of numbers do you get out of an absolute value? Let me just approach it like that. What kind of numbers do you get out of an absolute value? You always get a positive. When is a positive greater than a negative? Always. So you have to recognize that. Okay, you have an assignment right now? The assignment is 5/5. Okay, and it's on Alex, and it's due today. Okay, be safe. God bless. We'll see y'all. Wait, have a good weekend. Yeah, we'll do that.